Okay, so last time we were talking about for loops, and we already covered this, but just for the sake of refreshing everyone's memory, if here's a simple for loop, like a for each loop in Python, I would have something like a string, hello, hello, of course, like the string hello, of course, is a series of characters. You could think of this string as just like, it's just a bunch of characters. And so for each C in a string, print out C. Now note that the fact that it's the letter C, that's just the variable name for each of the things inside C. So the first time through the loop, C will be H, then E, then L, and so on. The fact that it's C has nothing to do with the fact that it's a character, it's just a coincidence. Oh, also, remember last time we were asking what cout means? I looked into it. Apparently, console out is what most people think it means, because it's reasonable to think that, but it's not. It means character out. So there you go. Apparently, it's a common misconception that it's console even. So I didn't know either way. So thank you for making that an interesting fact for today. But yeah, back to this. So the fact that it's C, it could be anything. It could be B, it could be Bob, whatever. It doesn't matter. It's just each thing in that series of letters. In C++, we would do it like this. C, I picked C just because, and I've got the string, but I don't say like for C in. I say for character C, it's going to be a variable, it's the variable C, and it has to have a type, and its type is character, char, car, whatever. And then colon is like the in. It means like in, kind of. Not really, it's just that's what it would mean here in parallel to Python. It works like in Python if we had a list. So for thing in the list, print out the thing. It's going to basically do the same thing, except this time it's a list, it's just general. If we had an array in C++, we would do it like this. But then, remember last time someone brought up, well, does that mean you can't have like different types in that array? So if we had like a counting for loop for I in range 10, that would of course do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. C++, you would do it like this. Why? Because it means for, start by creating an integer I and start it at 0. That's where we're starting, 0. Well, this condition's true. Well, I is less than 10, so 0 less than 10, of course. So that condition's true. We're going to execute the inside of the loop. And then as soon as we finish executing all the code inside the loop, we do that last bit in the top line, the I++, and that means just add 1 to I. So the first time through the loop, I is 0. What's it going to be the next time through the loop? 1, exactly. Then 2, and then 3, and so on. It's going to be different, but this is going to be some of the most common types of for loops you'll end up writing in this class. For I starting wherever, and well, this condition, probably like a less than type thing, I++. I is the conventional character, our variable name we use. If you've got nested, like ij, whatever. Here's a weird example. Again, I started at 17. Why? Because I can. And that condition, I is less than 100,000 or I mod 22 is 0. Okay. I equals I plus 81. I'm incrementing by 81. Why? Because I'm just showing you an example. If we had like a counting for loop, so like if I wanted to get the length of the list, so the length of this list is 1, 2, 3, 4. So that len list, what's that going to be? It's going to be 4. If I say range 4, that gives me 0, 1, 2, 3. So I would be 0, 1, 2, 3, and of course that's just the indices for that list. I would just do it like this in C++. Now, one thing to note about C++ is with your standard basic old simple arrays like this, you can't ask it how long it is. You have to know how long that array is. In Python, you can say, hey, list, how long are you? How many things are in that list? It'll tell you. C++, it won't do that. You have to, like, when you create it, you put 4 things in it. You have to say, but its length is 4. Yes?
Do you have to specify the length in, like, the square brackets when you declare it?
You could, but you don't have to. In this particular situation here, it would have figured it out. A lot more on arrays soon. Don't think this is the only bit I'm going to be talking about arrays. We're going to have lectures on arrays yet, so don't worry too much about it. We're going to talk about static and dynamic arrays, but more on that in a little bit. There we go. So, like I was saying before, the point of this lecture is not that you're going to look at this and say, now I know C++. That's not going to happen, and don't expect it to happen. I'm not expecting you to memorize all this. I'm just showing you, look how similar it is. And based on your observation of how similar it is, then you know that you should be able to Google this, figure it out. Oh, this is how I do the for loop in Python, or in C++, I forgot, you know? It's to show you that you are all capable of, like, you can do this. It's just to show you it's not that different, actually, and you can continue independent learning just like you did last semester. So yeah, the only way to get good at this is to practice, so go practice. People who do poorly in this class, it's the people that don't practice, so go practice. Where to practice? Wherever you want. Use Caddis. So those of you from last semester, we used Caddis. So maybe a good place for you to start is go to those problems you solved already in Python, but solve them in C++ now. You can change the language. That's a really good place to just start practicing. For those of you that came from the engineering side who didn't use Caddis, go sign up for Caddis and just start solving problems in Caddis. Caddis is a great place to figure it out. For those of you that don't know what Caddis is, it's a website designed, it's like a big repository of like programming competition style questions. And it's a really good place that you can sort the problems by difficulty. And if you start tackling the easier ones, those are ones that you are capable of solving. It's a good place to just practice problems. There's a lot of other places you could go too, but yeah. Anyways. And who wants to take a wild guess where that link will go if you click it? How did you know? Did you click it or did you just know me that well? No answer. Okay. Any last questions about that stuff? That was very superficial. You probably still have a bunch of questions, so don't worry too much. We're going to be doing a lot more detailed stuff as we go. Yes?
The way you were like on one of the slides assigning like a string, and you had like standard library before it. The string's like different.
This here, yes. So in Python, we don't need to say the type before the variable, right? So we could just say the string. Now, in C++, we always have to say the type. So if we want to make a variable called a and it's going to store an int, I have to say int a equals whatever. Now, by default, in basic old boring C++, you don't get strings. Strings don't exist. If we go back in time, you would literally do like an array of characters to mean a string. That was a real pain. We don't do that way anymore because forget it. But what they've done in C++ is if you include the standard library, kind of like importing math, right? How you get all that stuff for free. If you include standard library, you get like the string type. So because it's not there for free, we have to say from the standard library, use the type string. So std : string, and then it's like, okay, that's its type. The other types, we didn't need std in front of it because those are just like the basic old primitive types that we've had, like the integers, characters, doubles, booleans, and whatnot. Yeah. Yes?
Is it, I see you put like std : is it best practice at the top of the file just to write including namespace std?
That's a heavily debated thing, actually. A lot of people would argue, yes, absolutely, because you're just using the standard namespace like almost everybody, especially at this stage of programming, you know. Put it there, you don't need it anymore. Besides, that std : can confuse new programmers, so maybe you just throw that at the top and it eliminates it everywhere else. The problem, though, with doing that is you can get, there's a number of reasons, but like namespace pollution's a thing. You could imagine a world, and this happened to me. Years ago, this happened to me, where in the standard library, I assume it was a standard library, I included the standard library and I wrote a function called like sign to do, like I didn't write it, sorry, that assign function is inside the standard library, and it will calculate the sign of whatever value you give it, right? Now, the problem was, I wrote my own function called sign as well, but it was somewhere else. Now, when I say, like using namespace std, I eliminate the need to put std : in front of the things. But now, I've got the standard library sign and my sign that the program I'm writing knows about. And if I call the function sign, how does the program I'm writing know which one to call? Well, am I calling the one from the standard library, or am I calling the one that like you wrote? So that becomes an issue. So when you write std in front of it, you always know where those things are coming from. There's no ambiguity, which is a good thing. We don't want ambiguity in programming. Can someone do me a big favor and just close that door? You had your hand up?
Yeah. You say there's no way to find the length of an array?
Yes, if we're doing like the standard old boring arrays. There are like fancier ones, like there's the standard libraries arrays, which you can use, but we'll talk a little bit more about that later. Yeah. Yes, at the back.
So if you decided to include standard library at the top, is there another way you could put, so for your sign example, is there another way you can put from wherever that came from, : sign?
Honestly, I don't know offhand. Maybe there is. I wouldn't be surprised if there is, but I also wouldn't be surprised if there wasn't. So I honestly don't know. That's something we can look up some other time, yeah. Anything else? Okay, cool. So we're done with that. No, let's go to the beginning. Don't spoil the fun. Okay, pointers. Has anyone ever heard the phrase pointer before? Wow, a lot of people. So a bunch of people remember it from me talking about it last semester. Now, has anyone, so for those of you that took the C version of last semester, did you deal with pointers last semester? Yeah? Did you like them or dislike them? Who raised your hand if you didn't like them? Raise your hand if you loved them. Okay, nobody liked them. Okay. Raise your hand if you haven't used pointers really before, but you kind of have been warned to be terrified of them. Not based on what just happened, about how everybody hates them. 1/2 person. Okay, that's good. Typically, people have a hard time with pointers because when they're taught, they tend to be rushed. It's like, oh, by the way, this is a thing. In reality, pointers are actually, I don't want to say simple because people do struggle with them, but it's like once you get it, it makes perfect, like it's like, oh yeah, duh, right? But of course it's not, it's computer science. Nothing really is trivial to get. That's a given. But we've got issues where people, they think they're terrifying, so they think they're more complex than they are. It's actually not too bad. And last semester, or last year, that's going to be annoying. Last year, I think the group actually had a really good time with pointers because we took our time and we made sure to make sure everything was very well understood. So, let's start with pointers. So the point of this lecture is we're going to see how pointers work, see how useful they are, and see how they can mess you up pretty bad if you're not paying special attention. Now, I also said a lot in last semester, for those of you coming from Python, basically anything that was like not a primitive type, that was an object, it was all pointer stuff. So, like remember last semester how we had issues with pointers? Well, if you have two like pointers pointing to the same object, and through this reference you change it, and then suddenly like, oh, well in C++ it gives you more flexibility. It gives you more flexibility. It's like, do you want the variable to be a pointer to that thing, or do you want the variable to actually be that thing? So now you have the ability to make those decisions, where you can have this weird pointer issue, or if you don't want that weird pointer issue, you can make it like actually the same variable, like you eliminate the pointers. So it's actually, it gives you more flexibility. But of course, what's the saying? When they give you more rope to be flexible with, what's the saying? How does it go? Come on, nobody knows. All right, well, maybe we'll talk about that later. So pointers. We make a variable. We often, a lot of times in computer science, will visualize RAM as kind of like a big array. So you kind of think, of course, none of the markers are ever any good. Let's try this one out. Ooh, that's much better. We like to visualize, also whoever erased before is not very good. So we often like to visualize RAM. It's just kind of like a big series of like boxes we could put stuff in. Now, the actual size of the boxes, let's not worry about that too much right now. But we kind of think of them as arrays. Or like, you know, you could think of them as like mailboxes on a house, whatever. The point is there's a contiguous thing. I can address these things and they go up in increasing order. Like this is address 1, 2, 3, and so on. Kind of like lists or arrays. So if I make a variable and I call it init, right? And I say int init is 5. So here's what the computer's going to do. It's going to say, oh, they're going and they're making an integer variable called init. And because it's an integer, I know how much room it takes up inside of here, so I kind of set that all up for the programmer. So this is what the computer's doing. And I go and I say, okay, put the number 5 in there. There, 5. Great. So init gets me there. In fact, I'm going to just draw an int here. So init gets me there. Like that's what it is. If I say init and I ask you the question, what's in init? What's the answer? Everybody yell it. It's 5. Perfect. No trick questions. That's how it goes. The code makes a variable called init and it assigns the value 5. The value 5 is stored in RAM somewhere. I'm not in charge of where that goes, really. The computer is just going to go, like the operating system is going to go find, oh, here's a piece of RAM, let's just put it right there. Yeah, the operating system does it. Unlike Python, C++, I shouldn't say unlike Python, but very explicitly and very easily, C++ makes it very easy to ask the computer, okay, so we just made this variable called init, and it's number 5. But where is it? Tell me where that number is. Tell me where that is in RAM. Tell me where. In Python, we didn't have to deal with this. We didn't care. But what if we do care? What if we really want to know? I can ask the computer, okay, so you just made a variable called init, it's an integer, and it's got the number 5 in it. But where is that? I want to know where that is. So we can ask that question. We use the ampersand. Now, the ampersand, depending on its context, means address of. Now, ampersand is used a lot, and it will mean different things in different contexts. But this is going to be one of the uses of it. Where have we seen ampersand already used so far in this class? And, yeah, exactly. Where did the and symbol go? Well, when we wanted to and. Yes. So, yeah, depending on how it's used, context sensitive. When we have an assigned variable, when we have a variable, listen up, because this is a point of confusion, but when we have a variable like an int, when I've already got this thing, and I want to ask the question, where are you? All I have to do is put the ampersand in front of it, and then the computer gives it back to me. Have a look at this code. I created a variable called init, and I assigned it the value 5. Then I print out init, which is going to be 5, followed by the string is at, followed by ampersand init. And what that's going to do is it's going to go look and find where in the computer, it's not going to have to go look and find, it just knows. It's going to tell you where in the computer that variable is. So, for example, this is what would happen if I run it. Now, be warned, the fact that I have 006FFDC0, every time I hit run, I'm going to get a different result. So if I run it right now, you won't necessarily see that, so be warned. But this is what it would look like, presumably, if the variable was stored at memory address 006FFDC0. So F5 is at there. Why? Because that's where they put it. If I run it again, I'll get like a different result. Right? Every time I hit run, I'll get a slightly different result. Any questions about that? Yes?
Is that because every time you run it, it saves it in a different place?
Yeah, so technically it's possible that it goes to the exact same spot, but it's like I run the program, and the program says create a variable called nint, it's going to be an integer, and put the number 5 in it. Then the operating system goes, let's put it here. Then the next time you hit run, and so the operating system is going to be like, oh, okay, I need to go make a variable called nint, it's got the number 5 in it, where am I going to put it? And it's going to go over there. It just decides every time. It's going to put it in what they call static RAM, but more on that later. Yes?
Is that 006, all that stuff, is that supposed to mean something to us as the program?
Yes. That is literally the memory address. If we go to RAM, all RAM has a memory address. It starts at like 0. Then goes to location 1, then location 2, then location 3, then location 4. So that's just a number. 006 FFDC0. That's just a number. Now, raise your hand if you're thinking, well, that's a weird looking number. A bunch of people in here. You're right. But the trick here is that's not a decimal number. That's a base 16 number. That means, who here knows what the number 1 means? Like if I write this, who knows what that is in, here, let's start simpler. No, well, I can start over here. Let's start over here. We need more erasers in here. The first time I go through this, this is going to seem rather silly and simple, but just go with me on it. We're going to start with the symbols we use in base 10. We all know how to count in base 10. That's just like the numbers we use every day, right? So if I give you this symbol in base 10, what does that mean? It means 0 in base 10. Very good. Then I give you this. What does that mean? That means 1, 2, 3. So what's the pattern? Whenever I add a new, I'll go to like, let's go here, 8. Whenever I add 1, I just move to the next symbol, right? To mean the next number. So what's 8? What's the symbol 8 mean in base 10? 8. It means 8. What's the symbol 9 mean in base 10? 9. So let's say I have the quantity 10. I don't have a single symbol to mean 10, do I? So what do? You start over, you go back to 0, but then you increase the preceding digit by 1. So what's the preceding digit in front of 9? It's 0. That's just, we just don't write it. So we increase that, but then we start this back over. So 10 is 10. Why? Because, well, what comes after 9? Well, we have to loop back to 0, but then the 0 in front of the 9 we incremented by 1. So what comes after, what's 11? Well, it's 1. We just start over. We just start increasing this digit, right? So that's base 10. Let's go to binary. If I give you this in binary, or pardon me, if I give you this number in decimal, what is that? How do you write that in binary? Who knows? It's just 0. Preceded by an infinite number of leading zeros, whatever. If I want to represent the number 1 in binary, what do I do? It's just 1. We don't need the preceding 0, really. So far it follows the same rules. But here's what happened. This was base 10. What happened when I got to the thing that the base was in? Base 10. In base 10, so what happened when I got to 10? Well, from 9 to 10, I ran out of symbols. So I had to reset this one and then increase the next one. In binary, we only have 2 symbols. So base 2, 2 symbols. In decimal, how many symbols do we have? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I only have 1 and 2, 0 and 1. I can't, there's no such thing as the symbol 2. So if I want the number 2, what do? Well, I reset this, and increase the one before it. Then what happens when I do 3? 1, 1. Why? Well, I just increment this. What if I want 4? Well, I go to increase. Oh, I can't do it, so I have to roll this over, go, oh, I got to roll this one over because I run out of symbols and add the 1 in front of it. Right? So here is base 16. Let's go over here for this. If I have 0, what do you think that is? 0. Dot, 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 dot. We get to 9. Well, that's 9. How do I represent 10 in base 16? A. Why? Because someone somewhere was like, let's make it A. We're out of symbols, but we want to be able to count higher, but we want a single symbol to mean, so it's A. So raise your hand if you didn't know it was A. Okay, so you didn't know. Take a wild guess what 11 is going to be.
Go with B.
B! Wow, you're so right. What's 12? 13. 14. 15. Now, based on everything we learned so far, what would 16 be? Who said G? You're wrong. Because we ran out of digits. We have 1, 2, 3, 4, 5, 6, plus the 0 through 9, which is 10. So there's already 16 digits. We're base 16. We only have 16 digits.
Oh, but use a G in music.
Well, that's different. I'm so happy someone said G. But it's not G, because we ran out of symbols. So what was the rule before when I ran out of symbols? Exactly. Roll over. So what does that mean? Return this to 0, but then add 1. So the digits, the hexes, I don't know what you call it, the hex number 10 means 16. If I gave you something that was 10 in binary, what would that mean?
2.
If I gave you 10 in decimal, what does that mean? If I gave you 10 in base 71, what would that mean? 71. 71. Because we keep just adding weird symbols for the single 1 digit. That's an interesting thing about the number systems. Anything that's like a 10 is whatever the base is. Kind of cool. Long story short, to your very simple question, what the heck is with that, like F's and whatnot? It's actually a number, but we are using a different number system. And we like that number system because it's easier for like binary and whatnot, because it's a nice multiple of like 2, but then of course we've got like our bytes, which, 8, all that stuff. Long story short, it's a number. It's not a digital number. It's not a decimal number, but we could convert that to decimal, and that would literally mean which address is it at.
Should we do anything with it, or is it just that's for our knowledge?
Just for, as of right now, this is just by the way. Any other questions about this? Nope, we're all good? Okay. So, instead of simply printing out the memory location, I can remember it. I can save it in a variable. And I would do it with something like this. First, I've got an integer variable, except this time I called it my var. And what am I storing in it? 25. So what is my var? It's the number 25. What's its type? Int. How did you know? Well, it said int right in front of it. So now, though, on the next line, well, after the variable, or the comment, pardon me, I have int star foo. Int star, what the heck? The star, when it's next to the type, like in the declaration side, means pointer. It means, int star is different than int. Int star means the type integer pointer. It's a pointer to an integer. So, when I ask ampersand my var, what's that going to give me? Exactly, the address of my var. But the address of my var isn't an int, right? I mean, it kind of is, because we can think of it like that, but it's not really. As far as the computer is concerned, it has a whole different type. It's a pointer. And the thing at the end of that pointer is an integer. So it has its own type. An integer pointer. That's it. So have a look at this code. Take a moment and try to think to yourself right now, what's where? Take a moment, think about this for a second. What is where? What is my var? What's its type? What's foo? What's its type? What's actually in it? Yeah, just take a moment, think about this. Yeah.
So can you have double star or string star and that'll do the same thing?
Yep. Double star would mean a pointer to an integer. Yeah. More on that in a moment. We can get weird with that type of stuff. Stuff that you probably wouldn't actually really ever do very commonly, but you could do it. That's often what ends up being fun in computer science. It's like, can I do this? If you're following the rules, you can do whatever you want. So this is what we would think. If it just so happens that my var gets stored in memory address 1776, it's going to have the number 25 in it. But foo is going to store 1776, and bar is going to store what's actually my var. So what's in my var? 25. What's in bar? 25. Why? Because, well, I said bar equals 25. It just copies over the contents of what's inside the variable. This was a big theme from last semester, right? Always copy over the contents of what's actually inside that memory location. And this came up because a lot of the stuff in Python, all those objects, those are actually pointers to the objects, those variables. And what's in that memory location? A pointer to that object. So when I use equal, it does the assignment of what the value is. What's the value inside that variable in the case of having a variable? But what would happen if I said, if I created a new variable called like int star fun equals foo? Well, it copies over the contents of that variable. So what would be copied over? 1776. Questions? Yes?
So if you were to change the value with bar, that would also change the value with my bar as well? Or?
No, because it's in a different memory location.
Okay.
But we can do kind of what you're thinking in a moment.
So it's like a deep copy?
Yeah, this is just a copy. I mean, I know what you mean when you say that, yes, for what you're thinking, yes. Other questions? Because this is the time to ask questions, because these are topics people struggle with a little bit, so I want to hear the questions. Yes?
So bar and my var aren't stored at the same location?
No, they're just wherever. I don't even know where they are in RAM. The computer just said, put it here. The computer knows where it put it.
Okay.
I could ask ampersand foo, and it would tell me the memory address. And I could say ampersand bar, and it would tell me.
So bar is just a variable with the same value, 25?
Exactly.
Okay.
And then I can come along and say bar equals 4. And then this picture would be exactly the same, except there'd be a 4 in here instead. Yep. Thought I saw another hand. Was there? Okay. So we just saw two new uses of the symbols star and ampersand. Where have we seen star used before in computer science?
Multiplication.
Yeah, multiplication. So now it's got a different usage, but it depends on its context. Ampersand between like the two booleans or whatnot, that's like a boolean operator, it means and. Ampersand in front of a variable means, well, no, tell me where this variable is stored in RAM. And then star, in addition to multiplication, could mean, well, create a variable that's a pointer to something of this type. So it's like a modification to the types, when the star is next to the types. We're going to see more uses of the symbols ampersand and star, and it's going to be annoying because they're used in very similar contexts, but the difference is important. And this, what I'm about to say, is often what throws people off a bit. So, dereferencing. What if I have the variable, like foo. Foo is an integer pointer. What if I have an integer pointer variable that says memory address 1776? What if I have foo and I don't really care that it's 1776? I care what's at 1776, or what's at wherever it's pointing to. Well, we can do that. Star. So if I've got this situation, I could take my variable foo, but put star in front of foo, and it will tell me where it is. Basically this. This is the same code as before, but I added one extra line at the bottom. Star foo means, now notice here that before star was next to the type, and that means modify the variable type. Here I'm using star next to an already created variable. So before it was when I was declaring the variable. Now on that last line, I've already got the variable created. Now I'm saying, okay, foo, but because there's a star in front of it, it means, okay, foo, I know you're a pointer to an integer. But tell me, like, go to where that pointer goes and give me what's there. So based on that information, take a moment, think, don't shut out the answer yet, I'm going to give you 20 seconds. What is where? What values in what variable and what not? And we could assume that 25, like my var, is at memory address 1776. So think what values are inside each of these variables. Okay, let's start with the easier ones. What's in my var? 25, good. Now, pretend my var is in 1776. That's the memory address. So what's in foo? Everybody.
1776.
Why? Because I'm saying my var, oh, but give me the memory address, oh, that's 1776, store it in the variable foo, which is an integer pointer, so it works. If I didn't have that star next to the int, it wouldn't work, because it'd be like, no, no, this is a different type. You've got a type problem. So foo is 1776. What's in var?
25.
120? Who said 120? It's 25. Why? Because, well, what was in my var? Well, it's 25. And then we put it into the variable var. Great. So now, of course, the real question, raise your hand really high if you know, this is just a poll, if you know what's in Baz, or if you're pretty confident you know what's in Baz. Really high, I want to see. Good. And the trick is, just follow the rules. There's no real trick. Take your time, follow the rules. So what's foo? 1776. But what does the star mean? It says, don't give me 1776. Give me what's at 1776. So what is at 1776?
25.
25. And then, so Baz will become 25. What if, right before, now here's the real test. And this goes to your question that you're asking moments ago. What if, right before that last line of code, I change it. And I say, right before that Baz equals star foo, I say, my var equals 0. Okay? Does var change?
No.
No. Because it copied over the contents, and that contents it's independent, it's separate. But what will Baz become? 0. Why? Well, because what's at foo? Well, it was 0 because I just changed what was at memory location 1776. Let's draw it out just to be super safe. I've got 25. It's at location 1776. I've got foo, and it holds, wait, that's, all right, and this is, what was it called? My var. You probably can't see this, but whatever. Just trust me. foo, it holds 1776, and it's at memory location, I don't care. Then I say bar equals my var. So I create another one over here called bar, and it's holding whatever is there, 25, because I copy that over. Then again, on that middle secret line of code that's not actually there, I go and I change what's in here to be 0. I only change this. This got me there. This, completely independent, it doesn't care what happens here anymore. That's all. Questions about any of that? I'm going quick, but I hope it's making sense. And like anything else so far in computer science, this will make more and more sense the more and more practice you get. Yes?
If you didn't print just the foo on the second line, would it like print out 1776 or would it print out 25?
Oh, if I didn't put the star in front of it, it would print out 1776. Okay, I'm going to take this code. So if I go here, let's do star foo. So you can ask the question, let's answer it right now. There's no discussion, we'll find out the answer. So I'm saying print out star foo, which should be what's its contents. Pardon me, the contents of what it's pointing to. And the foo should just be whatever's in foo, which would be 1776, or in our case, it's not going to be 1776, it's going to be some other arbitrarily large number. 2500BEFA3C. Great. By the way, the people at the back, can you see this code?
We can see that, but not the.
Not the other one. Yeah, I'll change the font in the other one, but this code's better than it was the other day. What happens if I do like? Is that good still? Is that good? Yeah. Would you like it even bigger? Maybe. Is that good? You like that? All right, we'll stop there just because I want to be able to see what I'm doing. Perfect. So there we go. What time we got? Okay, let's do our first lecture activity. We have until 12:05. Assume my var is stored at 1776. Basically, draw me what I already drew over there, but I'm going to erase it, so you can't cheat that much. Just show me, draw something kind of like this, just to convince me that you know what's going on about, well, this is the variable, this is its contents. The only one we know where it is 1776.
We let the copy what's on the PowerPoint.
Pardon?
The copy what's on the PowerPoint.
Sorry?
Are we allowed to copy what's on the PowerPoint? Sure.
All I care about is that you're paying attention enough. Do remember that I'm not overly picky for the lecture activities. I just want to see, can I look at it and be like, yeah, you got what you're doing.
Can you just repeat it like one more time?
Yes, so basically, here's what we've got. Draw me some sort of diagram that says, okay, this is the variable name, this is what's inside the variable, and this is where its memory address is. Of course, the only memory address we know is 1776. And then just kind of show me what it looks like at the end of this code if you were to run it. Again, I'm not going to be overly picky. So here's what we need. Has to be in before 12:05. So you have 5 minutes. Has to be handed in by you. Make sure to put your name, student number, and activity 1 at the top. And then hand it in here. It has to be in here on this seat before we run out of time.